Good day everyone. So we are now in the sixth chapter of statistical analysis with software application, which is the hypothesis testing. So in this video, what I'm going to talk about or discuss about the steps in hypothesis testing, the traditional method. Okay, for our learning outcomes, at the end of the lesson, you should be able to first understand the definitions used in hypothesis testing. Next is state the null hypothesis and alternative hypothesis. And then the last one is state the 5 steps used in hypothesis testing. So those our learning outcomes. Now let us define what is hypothesis testing. So the first definition that we have here is it is the decision-making process for each evaluating claims about the population based on the characteristics of a sample purportedly coming from that population. Okay, purportedly or allegedly. Okay, so again, it is a decision-making process. So in hypothesis, we make decision, but hypothesis testing, it is a process of decision making, which is we evaluate claims about the population based on characteristic of the sample. So our basis is the sample, and we're going to test it through population. Okay, so another definition is statistical hypothesis. It's the conjecture about the population parameter. So this conjecture may or may not be true. So in this process of hypothesis testing, there involves two opposing hypotheses. Okay, so these two hypotheses are created or formulated for it to oppose each other. So if the one hypothesis is true, then the other hypothesis must be false. If one of the hypotheses give an 0% chance to happen, and then the other might be of 100% probability. So these two hypotheses are called the null hypothesis and then the alternative hypothesis. So those are the two types of statistical tests. So now let us compare those two types of statistical hypothesis. Okay, so try to look at this table. So the first column is the null hypothesis, and then the last column is the alternative hypothesis. Okay, for the null hypothesis, we use this notation, which is H0. And then for our alternative hypothesis, we have H1, or some other books define it as HA. So for each definition, for the null hypothesis, it means that there is no difference between the parameter and the specific value. The specific value is came from the sample. Okay. While in alternative hypothesis, there is a difference between the parameter and the specific values. Okay, so those are the differences of those. Again, for the null hypothesis, no difference, and then for the alternative hypothesis, there is difference, or there is a difference. Okay, so now through those two definitions, let us now state the null hypothesis and alternative hypothesis on each situation. The first situation, or situation a medical researcher is interested in finding out whether the new medication will have any undesirable side effects. The researcher is particularly concerned with the pulse rate of the patient who take the medication. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the medication? The mean rate pulse of the population under study is 82 beats per minute. Okay, so here in hypothesis testing, okay, first we need to identify the the mean, the population mean on a given problem or in a given situation. So in this situation we can see or we can analyze the mean of the population, which is 82 beats per minute. So therefore, automatically, the mean of the population is our null hypothesis. Or we're going to declare the null hypothesis mu is equals to 82 because or the population mean is equals to 82. Now let's go back on the first statement. Okay, the medical search is researcher is interested in finding out whether the new medication will have any undesirable effects. Okay, the researcher is particularly concerned, okay, with the pulse rate uh, of the patient who takes the medication. Will the pulse rate increase, decrease, or remain unchanged after the patient takes the medication? The mean pulse rate of the population under study is 82 beats. So if this is our hypothesis or the null hypothesis, okay, which is mu is equal to 82, therefore we can declare as the alternative hypothesis mu is not equal to 82. So why? So the null hypothesis specifies that the mean will remain unchanged. Okay, so as we can see, the mean remain unchanged. Okay, and the alternative hypothesis states that it will be different. Okay, so this test is called the two-tailed test. Okay, so later on we're going to talk, we're going to uh, discuss about the tail test, two-tailed test, and then one-tailed test, and then the keywords we're going to choose or to find, okay, in a certain situation in order for us to declare if it is two-tailed or one-tailed test. Okay, but in this case, okay, we're done stating the null hypothesis and then the alternative hypothesis. Okay, so we use unequal because of this word to remain unchanged. Okay, next, situation number letter B. Okay, a chemist invents an additive to increase the life on an automobile battery. If the mean lifetime of the automobile battery without additive is 36 months, so what is her hypothesis? Okay, so again, first thing first, we need to identify the population mean. So in this situation, we have a hint. If the mean lifetime of the automobile battery without the additive is 36 months. So therefore, the mean is equal to 36 months. So for our null hypothesis, mu is equals to 36. Now, let us identify the alternative hypothesis. Okay, going back to the problem or situation, okay, it was said or it is said that the chemist invents an additive to increase the life of an automobile battery. So in this case, the chemist is not yet sure, okay, if the battery will increase or the lifetime of the battery will increase. But uh, in this case, he invented or he invents an additive to increase, okay, the battery life. Okay, so therefore, the keyword increase, we were going to use the keyword increase here. So for our alternative hypothesis, so we can say that uh, mu is greater than 36 because the additive is to increase. Okay, there's in this case we can say that it might be, okay, greater than 36 because of the word increase. So in this way, in this situation, so the chemist is interested only in increasing the lifetime of the batteries. So her alternative hypothesis is that the mean is greater than 36. So the null hypothesis uh, in that mean is equals to 36 months. So this test is called the right-tailed test. Okay, one-tailed right-tailed test. Okay, situation letter C. Okay, so now the contractor wishes to lower heating bills by using a special type of insulation in the house. The average of the monthly heating bills is 78. What is her hypothesis about heating costs uh, with the use of insulation? Again, so first thing first, we need to declare the hypothesis by identifying the mean or the population mean inside the problem. Okay, so as we remember, mean is also called as the average. Okay, the average. So meaning to say, the average or the mean is $78. Okay, so therefore our null hypothesis mu is equals to $78. Okay, now let us state the alternative hypothesis. Okay, using the problem or using the situation. Okay, so let's try to look at the keywords or the phrases that we can use in formulating the alternative hypothesis. Okay, the contractor wishes to lower, okay, to lower the heating bills by using a special type of insulation. Okay, so we can say since it is to lower, so therefore we can use the less than symbol. So therefore, for our alternative hypothesis, mu is less than $78, okay, or heating bills. Okay, so to state hypothesis correctly, researcher must translate the conjecture or claim into words into mathematical symbols. So like what we did a while ago, we remain unchanged, increase, to increase, and to lower. So those are the keywords or the conjecture, uh, and the keywords that we can translate into mathematical symbols. So here are the other symbols. Okay, so there are four basic symbols used in hypothesis testing rather. Okay, those are the equal, the not equal, the greater than, and then the less than 2. So the symbol with corresponding definitions. Okay, let's move on to the different types of tests. Okay, so what are those? Okay, so those are the two-tailed test, the right-tailed test, and then the left-tailed test. So now, how can we identify if the given situation or problem has a two-tailed test, if it is right-tailed test or left-tailed test? Okay, so let's try to look at this one. Okay, so our main point here in order to identify what type of test is the given situation represent. Okay, let's try to look the alternative at the null hypothesis and alternative hypothesis, particularly in the alternative hypothesis. In two-tailed test, we use less not equal, okay, not equal symbol. Okay, in right-tailed test, we use greater than symbol, and then in left-tailed test, okay, we use less than symbol. So those are our keywords or key symbols. or our hints in order to identify what kind of test or what type of test, okay, represent in a given situation or problem. Okay, next. Okay, hypothesis testing common phrases. Okay, so this will help you in order uh, to know what symbol or comparison symbol we use, okay, based on the given problem. First is greater than. So the symbol or phrases, the symbol is greater than, and then the phrases commonly we see or in a given problem are is greater than, is above, is higher than, is longer than, is bigger than, and then is increased. Okay, so those phrases symbolize a greater than symbol. Next, the less than symbol. So these are the phrases that we can find or in a situation or problem. So is less than, is below, is lower than, is shorter than, is smaller than, is decreased or reduced from. Next is for equal sign. So it is equal, is the same as, has not changed from, and then is the same as. Okay, and then for the not equal sign, so it is not equal, it is different from, has changed from, and is not the same as. Okay, so those are the phrases na pwede natin gamitin or we can look inside this given situation. Okay, so let us state the null hypothesis and alternative hypothesis for each conjecture. So, tignan natin kung kaya natin. Okay, example number 1. The researcher thinks if expectant mother use vitamin pills, the birth weight of the babies will increase. So the average birth weight of the population is 8.6 pounds. Okay, again, state the null hypothesis from the given. Okay, our keywords is the mean of the population or the average of the population. So that is 8.6. So for our null hypothesis, we have mu is equals to 8.6. Now for alternative hypothesis, we will find out or we were going to look for the keywords or common phrases stated a while ago. So in this case, the researcher used increase. So therefore, our alternative hypothesis is mu is greater than 8.6 pounds. Okay, next, example number 2. An engineer hypothesized that the mean number of defects can be decreased in manufacturing process of compact discs by using robots instead of humans for certain tasks. The mean number of defective discs per 1000 is 18. Okay, now let's declare or state the null hypothesis. So the mean is 18. So for our null hypothesis, mu is equals to 18. Then for our alternative hypothesis, the engineer used the word decrease. So therefore, for our alternative, mu is less than 18. Okay, and then for third example, okay, so we have the psychologist feels that playing soft music during the test will change the result of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the score is 73. Okay, state the null hypothesis. Mu is equals to 73. And then for the null hypothesis, for the alternative hypothesis, okay, so the keywords is not sure. Okay, so therefore, for our alternative hypothesis, mu is not equal to 73. Okay, so after stating the hypothesis, the researcher design the study and the researcher select the correct statistical test, use choices an appropriate level of significance, and formulate a plan by conducting hypothesis. Okay, so in situation A, for instance, the researcher will select a sample of patients who will be given the drugs. So after allowing the suitable time for the drug to be absorbed, okay, the researcher will measure each person's pulse rate. Okay, if the pulse rate of the sample were say 83, the researcher will probably conclude that this difference was due to chance and would not reject the null hypothesis. But if the sample mean were say 90, so then it is all likelihood the researcher would conclude that the medication increased the pulse rate of the user and would reject the null hypothesis. Okay, so yeah, it is simply says that if the average, okay, or the mean is 83, and then when the researcher get a false rate of 83, so uh, it is not okay to reject the null hypothesis. But if the researcher get 90 or obtain 90 as a rate or pulse rate, so it is most likely to reject the null hypothesis. Okay, so the question is where does the researcher draw the line? So how could the researcher decided that the null hypothesis is rejected and the null hypothesis is not rejected? Okay, so this decision is not made by the feelings or intuition. It is made statistically, and that is the difference must be significant and in all likelihood due to chance. So here is the concept of statistical test and of the level of significance are used. So it is not just based on the researcher's feelings or intuition or presumption or assumption, okay, but it is based on statistical method or statistical test and level of significance. Okay, so now let us talk about the statistical test. Statistical test uses the data obtained from the sample to make decision about the null hypothesis should be rejected. Okay, again, see statistical test. It uses the data obtained from the sample, okay, to make decision about whether the null hypothesis is rejected, and then the numerical value obtained from a statistical test is called the test values. So in this type of statistical test or a statistical test, the mean is computed from the data obtained from the sample, and it is compared with the population mean. Then the decision made to reject or not to reject the null hypothesis on the basis of the value obtained from the statistical test. If the difference is significant, okay, the null hypothesis is rejected. If it is not, then the null hypothesis is not rejected. Okay, so first possible outcome in decision making. Okay, so here, here in the table, so you can see the decision about HO. and then the reality. Okay, so for example, okay, your decision is reject, but the reality, the null hypothesis is true. You made type 1 error. But if you do not reject what is true in the null hypothesis, you have the correct decision. Okay. Next one, if you reject what is false in null hypothesis, okay, so you have the correct decision. And if you do not reject what is false in null hypothesis, okay, you commit two type 2 errors. Okay, so for each type of error, for type 1 error occurs if you reject the null hypothesis when it is true. You reject the null hypothesis when it's true. Okay, but in type 2 errors, if you do not reject, if you do not reject the null hypothesis when it's false, so that is type 2 error. So I explained it in Tagalog. Okay, in my student before, sinasabi ko lang dito, kapag hindi mo pinaniwalaan kung ano yung totoo, so you commit type 1 error. Akin, hindi ka naniwala kung ano yung totoo, you commit type 1 error. Okay, pero kung naniwala ka, hindi mo na-reject, kung naniwala ka sa isang kasinungalingan, so therefore, you commit to type error or type 2 error. Okay, nagigets? Again, so our main focus here is error, hindi yung correct decision. Again, parang ganito lang yan. Okay, di-reject mo yung taong mahal ka, type 1 error. Okay, kung ikaw naman mahal na mahal mo yung isang tao, pero hindi ka naman niya mahal, you commit type 1, type 2 error. O diba, mas clear? Okay, next. So let us try to look it at in jury trial. Okay, that concept. Okay, so our null hypothesis is the defendant is innocent. And then our alternative hypothesis is defendant is not innocent. Okay, so in reality, the null hypothesis is true if it is innocent. And then the null hypothesis is not true or false if the defendant is not innocent. Okay. So now in decision, if we reject, okay, pag sinabing reject, hindi natin tinanggap yung decision, yung paliwanag niya, okay, hindi natin tinanggap, okay, yung mga evidences na pinakita sa atin, bagamat siya ay inosente, we commit type 1 error. Kinonvict natin, sinabi mo guilty ka. Okay, guilty ka. Pero inosente siya. Okay, sinentensyahan mo siya pero inosente siya, you commit type 1 error. Okay, pero kapag pinalaya mo naman, okay, pinalaya mo yung hindi inosente, you commit type 2 error. Okay, so marami ganyan minsan eh. Okay, nakukonbikta yung inosente, type 1 error yun. Napapalaya ang talagang guilty, ang talagang magnanakaw, you commit type 2 error. So the decision of the jury does not prove that the defendant did or did not commit the crime. Okay, still the decision is based on the evidence presented. If the evidence is strong enough, the defendant will be convicted in the most cases. If the evidence is weak, the defendant will be acquitted. Okay, in the most cases, so nothing will be approved or proved absolutely. So likewise, in decision making to reject or not to reject the null hypothesis, does not prove anything. And the only way to prove anything statistically is use the entire population, which is in most cases it is not possible. So the decision then is made on the basis of probability, and that is when there is a large difference between the mean obtained from the sample and hypothesized mean. So the null hypothesis is probably true and not true, and then the question is how large is the difference is necessary to reject the null hypothesis. So there is here is where the level of significance is used. Okay. So now let us talk about the level of significance. So it is defined as the maximum probability of committing the type 1 error. Okay, so this probability is symbolized by the Greek letter alpha, and that is the probability of committing type 1 error is equals to alpha again. Significance level is the maximum probability of committing type 1 error. Okay, we just focus in type 1 error because there is another way to solve the type 2 error, which is very difficult, unlike okay in the significance level or the probability of getting type 1 error is most easiest, okay, or more easier than committing type 2 error. Okay, so statistician generally agrees on using three arbitrary significance level, and those are 0.10, 0.05, and then 0.01. Okay, so in percentage, okay, the corresponding percentage of the significance level of 10.10 is 10%, 0.5 is 0.05 is 5%, and then 0.01 is 1%. So what those mean? So that is, if the null hypothesis is rejected, the probability of committing error 1 will be 10%, 5%, and 1%, depending on which the level of significance used. So here is another way of putting it. Okay, when a 0.10, so there is alpha is equals to 10% chance of rejecting the true null hypothesis. Okay, so when alpha is 0.05, there is 5% chance of rejecting true null hypothesis, and when the alpha is 0.01, so there is only 1% chance to reject the true null hypothesis. So those three significance level are most common use. Okay, so please please keep those things on your mind, the 0.10, 0.05, and then the 0.1. Okay, so critical values and rejection region. Okay, so these are the definitions. So for the critical values, it separates the critical region from the non-critical region. The symbol used for critical value is CV. Next is for the critical region or rejection region. So the range of the values of the test value that indicates that there is a significant difference and that the null hypothesis should be rejected. Okay, so for example, this is our normal curve. Okay, so this is our mean. Okay, so critical region. Okay, this is our mean. Okay, so for example, this is our critical region. Okay, so two-tailed test tayo. Okay, so this part is the critical region. Okay, so if the data falls in the critical region, so you should reject. Okay, the null hypothesis or the sample value falls inside the critical region. We are to reject the null hypothesis. And the non-critical or non-rejection region is the range, the value of the test value that indicates the difference was probability due to chance, and the null hypothesis should not be rejected. So if this is the critical region, okay, or rejected region, ito naman yung non-accepted region. Okay, or yung non-critical region. Ito yung white part na to. Okay. So, tingnan natin to. So, what is the value of z? Okay, if alpha is 0.1 or 0.10, 0.05, and 0.1. Okay, if z is alpha, meaning pag sinabing alpha lang ay walang over 2, ibig sabihin niya one-tailed lang to. So, dito tayo titingin for one-tailed. Okay, whether it is right-tailed or left-tailed. Okay, so we have 1.28 for 0.10, 0.05 is 1.645, and then 0.0.01 we have 233, 2.33. Okay, if in two-tailed test, okay, so both region, left and right, if the alpha is 10%, okay, so 0.1, so that is 1.645, and then for alpha is 0.05, we have 1.96, and then if alpha is 0.01, so we have 2.567. Okay, so we're going to use those critical region or critical values on the next video, which is the application and the computation of z. Okay, and then solving the null hypothesis. Ito yung mga steps. Number 1 is state the null hypothesis and identify the claim. Next is find the critical values from the appropriate table. Okay, so appropriate table kasi it could be left, 'di ba? Yun sa z distribution natin, pero ang ginagamit natin palagi ay from 0 to z sa z distribution, and then yon kasi mas madaling gamitin yon. And then the third one is the compute the test value. The fourth one is to make decision to reject or not to reject the null hypothesis. And then the last one is to summarize the report. So, okay, so for further understanding with regard to the hypothesis testing, okay, so I'm going to show those things on the next video about hypothesis, which is the z mean of the hypothesis. Okay, so that's all for today. Thank you for listening. God bless you.